going to have. Okay. Shall I begin?
Yes.
Okay. So once again, good afternoon, and today I will be teaching about CMM coordinate measuring machine. And my process is like I will be telling about how measurement is and why is it required, and then again I will go into the machines. Okay. So let us begin with quite basics. Please be frank and don't take it as kind of presentation, but kind of discussion. So, basic question: why is measurement required? Why do we need measurements? For precision. Yes. Of course, precision. Yes, that is what the main thing actually. So, if a part is required to 50 mm, if I want this box to be say 100 mm, it must be of 100 mm, because if I want to pack 100 mm box in a 50 mm box, it will not be possible. So the box also I have to increase the size. So that is what measurement is actually required. Similarly in gas turbines, in just like Hadiwani sir was telling about cranial implants, if there is a deviation of even micrometers, it will not fit properly in the brain. So it will not match with the brain. The same goes for the hip joint, so all those things. So that is why measurement is required. Then question comes, how do we measure it? How small or how big? For example, this is 5 blood cells, as my man might be knowing it. So white blood cells. So are they small or big? Small. They are small. Okay. If I compare with the platelets, small or big? Big. So we do not know how big it is, how small it is. Still they are cells, isn't it? I am telling this cell is big compared to platelet. It is big. What about this? This person is sitting in the cell and he is operating CMM. That is also a cell, but how big this cell is, how big that cell is. We cannot compare. We have to come with a measurement. Then again, coming to tall. How tall is it? A person is as tall as Burj Khalifa, or Burj Khalifa is as short as a person. We do not know. How do we actually quantify it? That is what the definition comes. Measurement is the process of finding the size, amount, or quantity of something by comparing it with a known standard unit. I will not touch quantity, I will not touch amount, I will touch only the dimension, that is size. Okay, so why actually that is required again? If you want to compare something, you will have to fix the standards. What is the normal standards what you are using? SI units. There are different CGS units and other units. Then quantification. Tools. For example, if you are measuring something, in what unit are you going to measure? So tools has to be used. Purpose. Almost all of us are researchers here. If you want to research something, definitely you have to publish or you have to show your research to somebody else. How will you show? In what quantity will you show? So that is what measurement is required. As ma'am was telling, accuracy and precision. When you measure something, are accuracy and precision same? Or they are different? How different are they? They have a small look. Low accuracy. This is the point where it is supposed to be. If it is close to this, it is more accurate. Is it accurate? No. The points, the repeatability is less, therefore it is low precise. It is not even close to the point, therefore it is low accurate. But that all the repeatability is there, we are getting the same points, that is accurate, precise, but it is very low accuracy. All of them are together plus they are at point. So there is accurate plus precise. So this is the basic difference between accuracy and precision. How do we define the accuracy and the precision, or how do we measure some objects? How do you show in the form of 2D drawings? So we use GiAN. I'm going very fast, I'm actually jumping building to building. Okay. So GD&T, geometric dimensioning and tolerance. So can any of you just mention, without saying this, what are the different types of GD&T forms? I'll explain. Straightness, how straight the body is. Flatness, how flat it is. Circularity, how circular it is. Cylindricity. Yeah. So similarly, we have several of them. Okay. Position means from one position to other position, how much accurate is it. So all those things is covered under the topic as GD&T. GD&T itself is a very kind of ocean. So this is a kind of this is one of the examples where we are using GD&T. So whenever you want to measure any object, definitely you want to show it in the form of a picture. If you want to convey, if you are an engineer, design engineer, if you want to convey to the production engineer or a manufacturing engineer, how will you convey? Convey will only be done through drawings. And drawings, you have to follow the GD&T rules. And again, using these drawings, a person who is in quality, he has to make sure that the part is under conformance. If it is non-conformance, if it is deviating from the drawings, the person who is in quality checking, he'll just reject it. Okay, so conformance, non-conformance.
This little boy is very good at pretending. He is a well-behaved and obedient child in front of his parents. As soon as his parents left, he immediately became possessed by the little devil. He picked up a slingshot as a weapon and attacked the little parrot in the cage frantically, scaring the little parrot to escape from the cage.
Good.
He ran around the room and finally hit the vase on the table. The little boy slingshot hit the vase and smashed it. When his mother came back and found the broken vase, she fainted on the spot. When he saw his parents,
She is fainting. Okay, so the thing is that he is a naughty guy. Similarly, our parts can be naughty. They might go off dimensions. What will happen then? There will be results. So this result will be and we getting beatings. Similarly, this part will get beatings. So what is going to happen? If there is a non-conformance of our part, what is going to happen? We have four options. We can do either rework, we can repair it, we can use it as it is, but only on the approval of the design, or else we can scrap it. So these are the four options we have. Okay, that is why this quality control is required. Then methods of measurement. How do we actually measure it? Either by contact or non-contact. So contacts, they are cost effective, easily we can procure it. Non-contact, they use very fine-grained sensors, and procuring them, maintaining them is very difficult. And there are different advantages as well as disadvantages also. So what are measuring devices? How are you going to measure the dimensions? We are basically focusing on the dimensions, so measuring dimensions. For example, we are using rulers. We can measure. What is the least count of this?
1 mm.
1 mm. If you are using a vernier caliper, it is also a measuring device. What is the least count of this? 0.1 mm. The number of dimensions, number of counts we are again we are just segregating it again. So it is basically 10. We are using micrometers. Least count of this? Yes, because 1 mm is divided again into 100 parts. This circular thing. So again we are having 0.01. So similarly, there is also laser tracker. So big parts you cannot adjust. I was discussing this. So CMM can be used only for small parts, but how about the bigger parts? So we have to go for laser tracking. Our focus is on CMM, which is basically the coordinate measuring machine. So I think so I have completed the basics, just an introduction, and the demo procedure will be like I will be showing the machine intro, then I'll start the machine, software setup I'll do, measurement I'll do. I have 4 parts, so we'll do some, because all of the printers which you have seen shown yesterday I have printed the same part in all of the printers. Okay, so we'll just do a comparison study of that, and then most probably I'll do one and I'll allow one of you or 2-3 of you to do the practice here, and then I'll export and then we'll compare it. Okay, so first thing is CMM machine intro. This is the CMM coordinate measuring machine. This is the bridge type. You can see this is a kind of bridge. This is made by Accurate. This company is in Pune, and this is 5.6.4 model. It means 500 in height, 600 in Y, and 400 in X. Okay. So this is called as the surface table where we place our parts, and we have to make sure that rough metal surfaces are not placed here, because whenever we are putting in plates on this one or heavy objects on this one, this gets scratched off. So this is surface table has to be maintained. And the basic parts of this is that we are getting a pressure line. The pressure is coming from there, is around 6 bars. But behind, sir, can you please check and tell me how much is the pressure behind? Here. Something is mentioned. How much has to be maintained and how much is it? Is it on? Okay. Okay. So then I'll make it on now. So 4.5 bar of pressure has to be maintained. And here we have the dehumidifier. We are having the power supply so that there is no uninterrupted power supply to this. And dehumidifier will because this is working on air bearings. You know about air bearings, right? You can fix it, sir. You can fix it. So it works on air bearings. We don't have a bearing separately. So air bearings will work here, and on the basis of that, because that has a very less friction. So the movement will be based on that. Actually, the engage button. because this was idle for a long time, that will get off. So surface table, we have the dehumidifier, pressure supply of 4.5 bars, we have the power supply, and this is the H bridge, and we have controllers. So we have some controllers, and these controllers are basically for the Renisha or the measuring head. So measuring head is of Renisha. Okay. So image head is used as a head. Then we have TP20 extension, and then the probe. This probe is made out of ruby. So can anyone tell me why ruby is used here, or any characteristics of ruby? Ruby is very costly, isn't it? It's very costly. Why do we use ruby here? Ruby is very.
So help lighting happen through?
It can be sometimes, but yes, it is very scratchless. I mean, it is very hard material, similar to diamond, we can say. Not almost equal to diamond, but similar to diamond. That is why we do not use diamond here. So it is scratchless because several times this probe is going to touch our body. If our part is getting touched several times, even water just craves out of the stone and it makes a way. So this itself is going to get scratched. That's why we use ruby, so that it is not getting scratched. Another reason, it is very much temperature resistant. So expansion and contraction of ruby is very less when the temperature increases or decreases. And for this environment, we have to maintain 20 degree plus or minus temperature for measurement, so that we get accurate measurements. So this is about the machine, and I will start explaining a bit about this software. So something you can see here, and I'll also start the Google meeting because the wire was not long enough, so I have started a Google meeting. I hope this will make a little bit clarity. So for starting the system, the first thing is that we have to give the power to the dehumidifier and the pressure supply. Then we have to give the power to the stabilizer. After doing the power, it will take around 5 minutes to stabilize. And then we on the UPS, we on the controller of the Renisha. Once the controller is on, I on my PC. Once the PC gets on, our state will be like this. There is something called as UCC server. So UCC server is basically a kind of buffer or a connection between the machine as well as the software. Okay. So first that buffer has to get on. So I'm on the UCC. I've already done on so that I can show it here. So if you do it on like this, it will show. I hope it is visible here. So this is the client tool. I have done the client tool on. So that is the client tool. That is the Renisha client tool. I have done it on. Now it is connected. So software where I am going to work, that is called as rational DMIS. I'll on the software and we'll get somewhat this kind of interface. This is a teach pendant. Some people also call as a remote controller. So most of the things we can control from here. While we are operating, you cannot sit on the PC and operate. So they have given the freedom. And explain a basic introduction about this interface. So this first interface, it will show the graphical viewer. So it will show the state of the probe. So this is the probe. It is towards bottom. Okay. Z axis is at top. Z axis is towards top. Y axis towards inside. X axis towards here. So before going for any measurement, we have to make sure. Otherwise, that might collide anywhere. So we are, as of now, we are sure that this is towards bottom. X, Y, Z coordinates are perfect. So these are the options which we are going to basically use. So first of all, we'll have to build the sensor. So this is the sensor button. We'll click here and build the sensor. Okay. So building the sensor means I have done the software, which is the hardware I have already installed here. So this is the Renisha MH8. I'll select here Renisha MH8 or else MH8. I'll search. I found it here. I added it. So it has come. The next is TP20. I'll search it. I got it. That is 38 mm extension. I have also used that. Then comes the bottom part. So which one am I using? Yes, I think so. This is it. So probe also I have added. So I am getting the final setup. Final setup is ready. My software knows that what is the hardware I have already installed here. Then I'll click on add. So this is added. Then I'll go on sensors. We can see here the name which we have created as now root SN4. Okay. So previously I have done all the setup and I've made one sensor which is GiAN demo. Here we can see A0, B90, A90, and B90, A90, B0. What does it actually mean? So again we have to do the software in which angles am I going to use this probes. Here I have a button. This is A angle. This is the B angle. Okay. So already I have told to the system that this is the angles I'm going to use. So I'll make this as 90. I'll make this as 0. B is 0. So this is one of the configurations. I have to see this is totally based upon your logic and aptitude. In which angle are you going to use your probe? You have to see your object. For example, it is this. I'm going to keep this object like this. If I use the vertical ones, basically 0, 0, it is not going to go inside and then we cannot measure the circularity of this. In that case, I will tilt it to 45 degree. The basically which angle? A angle I will have to tilt to 45 degree and B angle I can keep it as anyone. So then I'll have to probe it inside. So this kind of, it will come out of aptitude with the practice that which angles has to be added. So here are the options. Okay. So 0, A angle is there, B angle is there. We have different options. We can select either of the configurations.
We can add different angles.
Yes, we can add all the angles which is given. And this is extensive actually. This is more than enough. We can add the angles. So I have added 1, 2, 3, 4 angles I have added. Anyway, I am going to use only one, but I have added 4. Then we will keep on define and it will be defined. So our sensor is ready. So currently I see that A0, B90 is activated. If I click on here, right click, activate, it means 0, 0 is getting. It is telling me please rotate the sensor into A0, B0. Okay, I just loosen it. B0 is already there. I lose it to A0 and I have locked it. So now A0, B0, I have to rotate and I have done it. Then it's telling something, no. So it is already accepting it. So this activation, deactivation can be done. This is the previous time I have done for another demo. So I can activate this also. So depending upon the sensor you are using, which you have built up here, that will be activated. So this is activated. Next thing is coordinate I have already done. This coordinate setup is also required. The coordinate setup takes around 10-15 minutes extra. So I have done it already. We will directly go for the measurement. Okay? So that we have some time for practice also. So teach pendant, I'll explain the basics. So this is engage, disengage button. If I click on disengage, this MCU becomes off and whatever we do, it will not be translated here. If you want to engage it, I'll have to click on this again. This is the emergency button. If something goes wrong, just click on emergency. The machine will stop in as it is situation. This is speed override. So if you want to increase the speed of its movement, this has the speed of around 300 to 600 mm per second. So you can give it the maximum, say 600 mm per second, and we can just translate it. Then locking. Sometimes when you are moving this, because this is 3-dimensional at once, when you are moving this, it might go in X and Y also. You can lock X and Y as well as the rotation. You can lock it as per your requirement. If you are doing any kind of measurement, no need to go to the PC and select, no, the previous measurement which I have taken is not required. I will just click on that and I will cancel it. Similarly, I can do here also. So we will go ahead with one of the measurements. Okay. So this is the demo, and then we will go ahead with our printed parts. Okay. So on the top, I will make a plane. So for plane, how many points are minimum required? 3. If you want to have accuracy, how many points? You can have unlimited points, but try to keep it as maximum as possible. If there are 3 points, what is the planarity? Will it be equal to 1, or it might deviate, or how will it be? Planarity or flatness. You can say flatness. If you are using 3 points, it will be flat, totally perfectly flat border. So for this, I'll take more than 5. I'll take 5. So first of all, I have to engage. I click on engage. Now it is showing green color. If you rotate anti-clockwise, it will move up, clockwise, down, front, it means y-axis, back, it means minus y-axis, right, plus x, left, minus x. Before this, we have to check another setting here, is that the approach distance. This is basically used when you are automating this. If I want my sensor to be here, approach distance is how far it should go and search for the body. It cannot go for infinite place, okay? So I have kept at 1 because I'm not going to use any automatic here, autonomous here. Return distance, once it touches, how far it has to come back. If I want to measure something which is just 5 mm, I cannot retract it 5 mm, otherwise it will go and collide in the other previous body or the behind body. So I will give some retract distance. I have kept 5 as of now because this is compatible with 5. I can keep it 5 mm, 10 mm, 15 mm. So after touching that, it will go behind that much. After touching bottom, it will go up the retract distance. Then clear surface and all that is of a little bit different height. Okay. So I'll just touch on one of the body on the top. I'll move down and see. I'll just keep this override. Now it is going closer, so I'll keep the override very less, and then I'll move down. It is touching and coming 5 mm above. So one point is already taken. If I want to remove that point, I can keep here. So it is cancelling. It is not taking that. Okay. So let me take 5 points. 1 point I have taken. 2 points I have taken. 3 points. So now it will be perfectly plain. But I have to measure the actual thing. Normally what we do is that we take at equal intervals. Now I am taking randomly at some places. We take at some equal intervals. I have taken 4 points, 5 points. And then there is an option to tick here. I can give the name of it. So let me give the name as top plane. Top plane. And I click here, OK button is visible to what you see here. Okay. I'm sorry, I have done a mistake. So I have taken 5 points, but I have not selected a plane here. I'm supposed to measure a plane, right? So I have not selected the plane here. So what is the kind of object or form you are going to measure that has to be selected? Okay. So definitely I have to cancel all of them. So 135 is not. So I'll select here plane because I'm going to measure plane. Then again I will have to take 5 points. Two. 3 points. 4 points. 5 points. So now I'll click on this one and I'll make it as, I'll give the name top plane. Top plane. I have given the name. Now I get here. In plane, I have only one plane as of now measured, and that is top plane. I have given the name. Okay. So I'll take another plane here, which is slanted. With the same configuration I can do. I no need to change the angles. I'm taking 1, 2, 3, 4, and let the plane name be PLN1 itself. So I have 2 planes now. If I want to find out the angle between the 2 planes, because the plane is already, I'll show you. This also shows here what kind of planes it is there. Are you able to see it is forming? It will show a visual representation. So this is the top plane, this is another plane one which we have made just now. So we can have visual representation as and when we are measuring, and this is our tool head or the probe. Okay. So now what we will do, I'll cancel both of them, I'll delete them. And I'll go ahead with our printed part. I'll disengage this with our printed part. Before that, I want to engage this and move up. So I'll keep this part separate. I mount one of it. So let me mount. What was the first demo we had? We had SLA, right? So I mount the SLA. Hopefully it's can without moving. This might move. I'll keep the weight of this. Okay. So I'll start. On the top, it should be perfectly plain, isn't it? Because I have made this as a plane. This object actually, this model, this is actually it is looking like. Okay. So I will try to measure the top and I will find the planarity of it. So I have to click on plane here and I will measure how many points. Let me measure 5 points. One, 2, 3, 4, 5. So 5 points I have taken, and I will make it as top plane. I will give the name TOP underscore PLA top plane. Mine is ready. Then I go for the angle plane. One, 2. Monitor, okay? Because some of you might have to do this. I'll do one and remaining I'll give to you.
Can we do multiple parts at the same time?
Yes, of course, we can do. But again, you have to remember which part, which plane corresponds to which part actually. Okay, so I have taken 5. And this is angle. I'll make it as INCLINE inclined. PLN, so that I remember. Inclined plane. Then I'll go up. I'll also measure what is the distance between these two surfaces. So I'll take another plane here. 1, 2, 3, 4, 5. So for me it is right, so I will mention it as a right plane. Plane, so right plane. Then I go for left plane, I go top. One, I move up. 2, 3, 4. Yes, sir. So 4 planes I have taken. I have forgot to rename this. I will rename it as option of renaming. Okay, let it be plane 1 as we have. So right plane, left plane I have measured. I measure the distance between them, and then I will not do the circularity now. Okay, let me do the circularity also so that we can compare. So plane is done. Now what I have to measure? Let me measure circle. So I'll click on circle. So for circle, how many points are required to trace a circle?
3.
Minimum number of points? 3. Because 2 will give you just a line. 3 will give you a circle. I have taken 1 point, 2 points. Because it is same. For measuring circle, it must be on the same z height, isn't it? So I lock the z here. I have locked the z. 1, 2, 3, 4, 5. More number of points, more accuracy will have. So I have taken 5 points and then circle. So circle 1 I have done. So now what I have? I have the circle. I have 1, 2, 3, 4 planes. So this is the measurement part, and now I will disengage after moving into the safer place. I will disengage. So now part of measurement is done. I will do some analysis. There is an option here, construction. If there are several of the measurements what you have done here, and within that itself you want to digitally construct some objects. For example, 2 planes are intersecting. Then you want to find the line between them. Okay? So what is the line where it is actually touching? So that you can do. So all these constructions can be done here. You can construction, you can create points, intersection of lines, parallel lines you can make cone out of it. For example, there is a cone here. So I can take 2 circles and then automatically will form the line. So all those constructions can be done here. So we'll skip that part and we'll go for directly measurement. Tolerance. Okay. So I forgot to tell about tolerance. So what is GDNT? Geometric dimensioning and tolerancing. So something goes out of tolerance, there must be some repercussions. There will be some repercussions, isn't it? Just like the child was getting beating. Similarly here, upper limit and the lower limit. The difference between them that will be called as a tolerance. Okay, you might have seen in the GD the drawings plus and minus something, plus and minus. So that is nothing but tolerance. So here, what I am supposed to measure? Let me measure the distance between this plane and this plane. Okay, so this plane was written, I have written as right plane, and this is as plane 1. So I'll go to construction. Here will be something like distance. This is the distance. I'll measure the distance between them. Let us go first for the flatness. Okay, I'll click on flatness. So which plane flatness do I want to have? So I'll take the top plane, actual one, not the nominal. Nominal always will have the perfectly flat part. So I'll take the actual and I will drop it in the plane. Okay. For flatness, is there any reference required? No, because it will be comparing all the points with itself. So flatness here it comes like 0.01296. So that is the flatness we have got. If I click on accept, it will be showing in our report. So this is how our report is going to come out. So top plane, it should be, if it is perfectly flat, it should be 0, and now it is coming as, it is not perfectly flat, therefore the deviation is 0.0130. I'll go to this once again. I'll see the inclined plane. What is the flatness of this? So let me see the flatness of this. Again, that is 0.01296. So flatness is varying depending upon the planes. I want to find the angle between this plane as well as this plane, or else angle of slant inclination. How do I find? There is an option called as angle. Somewhere it will be angle. I click on angle. Then What is the name of this? Let me give the name as ANGLE. Inclination. INCLINATION. Inclination angle. So inclination, there must be always two features required for an angle, right? If you want to measure any angle, there must be two features, or else two lines or two planes or something, because only then you'll be able to compare it. So one, I'll keep it as top plane. I'll take the actual one. Second one is an inclined plane. I'll put it. Then nominal, it should be 50 degree. Exactly, nominal means exactly how much is it in the drawing. It must be 50 degree. But how much are we getting? It is 50.417437 degrees. Okay, so there is some deviation. So that shows that additive actually is not perfect. Okay, even though that is SLA, yes, SLA part. In the drawing, it might sometimes say that tolerance limit is different. So you can change the acceptable or non-acceptable limits. Okay, I click on accept. Again, you'll be able to see it here in this. The inclination angle, it is supposed to be 50. It is actually this much. This much is the deviation. I'm able to see it. So it's the kind of report as. Again, I'll try to find the distance between the two planes. I'll go to the distance. Then again distance, we need two features. I'll go to the right plane. I'll drag it here. Then I'll take plane 1. I'll drag it here. So distance, I think I have given as 40. Okay, so nominal is 40. Let me see if it is. Yes, so this is like this, so it is 40. What we are getting actually in measurement, it is 39 point something. So again, this also I'll accept. I have got in the report. What I have measured? Flatness of this, angle of this, distance between this, and let me see the circularity of this. I'll go to measure the radius, okay, or the diameter. Diameter of what? Diameter of the label. Which label? The circle. I'll drag the circle here, okay, and then I see here it as 24.930. So that is what it is showing us. In actual, let me see how much is this. Oh, I have not mentioned actually. So I think so it was 24 only. So 24 radius was there. 25? I think 25. Sorry, 25. So 25 radius I have given, but here how much do I get? 24.93 something. I'll accept this and I'll get in the form of the report. I want to save this report. After doing any kind of inspection, you have to save this and you have to compare with the given drawing which is given by the engineer. I'll go here and save. So it will save as a PDF file. Where do you want to save? I want to save in my folder. Demo12. Okay. So I save it. Okay. So this is how the basic measurement is done. Flatness I have got the inclination angle, I have got the what is this? Dimension between them, and then I have got the circularity. The diameter of it. Diameter is this much. And this one I can compare with. Actually, it should be, I forgot to mention it, 25. So I must mention it here in the software itself. It is 25. Okay? Is this clear? Basic understanding we have. Okay, one thing I forgot to ask. What is, this is coordinate measuring machine. What do you mean by coordinate? X, Y, Z. I mean location based upon the coordinates. X axis is there, Y axis is there, Z axis is there, how much it has traveled into which axis, that we are trying to manipulate it. Okay, so X, Y, Z. Every point which it touches. So mathematical model is continuously going behind the software. After it touches a point, it takes the coordinate of that exact point, and then it takes the coordinate of another point. When you click on plane, automatically using those points, it makes a plane automatically. Okay? If you are making the angle, it will make a plane first of all, and then it will make the angle between these two planes. So all those mathematics is going behind in the software. That is why these people are charging money for it. Okay, is this part clear? They want, so who is going to take the lead?
Which is the origin of measurement? Origin.
For measurement origin. So for this machine, we have the origin here.
Okay.
The first. I think so currently the origin has been set as home and it is behind.
Okay.
Okay, it is at behind. It has been set as origin. Top, it will go behind and X will come.
Correct. So with respect to that, it takes measurement.
Yes, it takes measurement with respect to that one.
There is no need to measure the origin whenever we perform this measurement.
Yes, it is required. First of all, there is a homing option. When you do it, automatically it will go to the home. So after that, there is no need of any kind of measurement. But yes, calibration is required. So for calibration, we have certainly. So this is given by the company people and it has some 29.9983 diameter. So we have to calibrate it and tell to the machine, okay, I am calibrating and this is what your measurement should be. Okay, so that is what actually is required when you are doing any kind of measurement. So calibration is required not often, every 1 year they prefer to do the calibration. So the head what we have here, there are other heads also available. I'll not take them out for safety purpose. So these extensions. So we have different kind of extensions. Okay. So this comes as a package. I think this is already I have used here also. So these are the extensions which we use for the probe. And this is another probe head. This is also Ruby. Okay, this is another extensometer what we can use here. This part, the probe part is removable, and you have to make sure that this is not falling and it is because this is very fragile, and you have to mount it back. Okay, so this mounting is done. So I think so. The report is ready. We have done some measurements, and somebody will take the lead, and I'll be supervising you, and you can take the lead for DLP as well as FTMs. Okay, they come. So I'll take this one to the left side. I'll engage this. I'll move it up. Up to what time do we have the demo?
3:30.
4. Up to 4 o'clock. Still we have a man.
Yes.
Yes, of course. I mean, drawing we cannot get. We cannot get the model. We can get only the dimensions, not the model. Yes. We cannot get the drawings, but again we have to go into the digital drawing. We have to make this plane, make this plane, try to intersect. Make this plane, try to intersect. But CAD model is not. CAD model it will be understandable. Mathematical model it will be understandable, but it will not give an output like later on. It will be only the numbers. So we do for DLP. So यहाँ पे भी क्या पीछे भी बैठे हैं ठीक है So what is the first thing? You have to on the software and remove all of this. Remove. Yes. Okay. We'll start with the measurement, and first thing is the plane. You can go with the plane. No, this is paid software of their own. 5.6.4. Accurate 5.6. Yes. So one is already, they have taken one point. Okay, go to the second point. Yes. So that is the Palab plane, right? How many points you want to take? 5, 6, 4 or 5. We can come closer so that we can see it. Four points are taken. You can tell. So now what we do? That is okay. So the flat surface is see, before I have taken the plate, now I am doing one. Yes, that is 0.1 micrometer. Release quantum is within the 0.1 micrometer. Very slowly. I mean, 0.1 micrometer cannot be measured. With accuracy of 0.1 micrometer, it can be measured. I mean, least count is 0.1 micrometer. For example, if you have a body which is 5.1 micrometer, then 5 it can be measured. So you have taken a plane, right? I take this inclined plane. I can see yes. So I select this is ellipse. Take now lock the Z. Lock the Z. Lock the Z. So we have created out of DLP, SLA, FDM as well as a composite printer. We'll see which is having the better accuracy. So, circle, right? Circle one. Okay, somebody else can come and take this and measure these two planes. One plane on this side and one plane on this side. You can add and then we will do the final dimensions. Nobody wants to take the lead? Nobody's interested. Okay, then I'll then let me myself to it. Okay. I think so this is not so interesting topic. What is it? It's not complicated. It's very easy. Rather than, see, if you want to measure the same thing with a scale, you can measure it very quickly. But will it be accurate? It will not be accurate. Just imagine having a robot and this person is dancing in front of your fingers. Then what can be better than this? So one plane I have taken, I'll mention it as right plane, and then I'll measure the left plane. Oh, all these things I was checking in circle, so this is rejected. I'll take a plane now. Plane, points. One, four. So I've taken plane, that is the left plane, then I'll take the right plane. Sangamitra, enough you guys come. Because the interns will have to learn. These people will live from here. So this plane you have to measure, okay? So this will go lock. So this way it will go to below. This way it will go up. Okay? Left, right, front, back. Okay? So this way on this surface you have to how many points? 5 points. And the points will show you.
Soft color material, even though he has inside so far that's try if it is not below, then we have आप उसको थोड़ा स्पीकर के
What is you measure the distance between front as well as the back. Okay? So measure this plane and then measure this plane. Okay? Go behind. Take it behind. Yeah. So now you are not able to see from one side. So go on that side and see. Measure 5 points on each hand.
3D printer में atom सिलिकॉन रबर डाला उसके मोल्ड उसको पेपर आने कुछ शेयर करना सर मुझे शो ये ऐसा चीज़ें से हम भी समझ आते हैं
So the second part
क्या
we are measuring again and again.
आप लोगों का रहता है
What happens is there is another feature. If you directly import this CAD model into this, and then this is my this is automatically it will understand where other features are there, and will program it in a manner that wherever you are doing it manually, it will take automatically doing CNC codes. Just place the part there, tell them through 3 or 4 probes that this is my plane, this is my plane. Automatically all the planes, whatever measurement we are giving, automatically all the things it will measure and give us the report at once. So no need to repeat it again and again by manually. So that is what happens in assembly lines. So each and every part goes under quality control of the vendor. Huh? You have to click here. You have to click here.
ये वाला
You have to take it. Then click here and you can delete it. This.
4D center
Deleted? I'll rename it as back plane. And I'll click. Yes. Now front plane. Only on the plane, not on the inclined surface. No need to go up to the edge, you can measure it in front also. Below? No, you have taken the guide minutes. Not on the plane.
मंडी से
Yes. Now okay.
मंडी तो वो तो पता ही
Actually, there is a certification for it, and there are people who are dedicatedly working on CMM itself, and they have always around starting from around
रिजोल्यूशन कर रही है स्टैटिक डायनामिक मल्टीपल फंक्शन कुछ आप क्लिक कर सकते हैं कुछ रिटर्न सर्विस कर सकते हैं मैं तो लिख के लिंक पे भेजता हूँ सारा इन्फॉर्मेशन अगर कोई पोजीशन है अभी तो मेरा फ्रेंड है उसका भी कंप्लीट होने वाला है पोस्ट डॉक ज्वाइन करने से पहले ढूंढ रहा है तुरंत टाइमिंग जाए
So now the measurement part is done. Click on disengage. Engage button is done. Click on that. Disengage. Engage. Disengage. Click on that. Yes. So now it has become red. Whatever I do now here, nothing will happen. I'll keep it done. Now take the measurements. Consider
करने को मैं इसको इनको जो 3D इसके पोस्ट प्रोसेसिंग
So we have to do the measurements now. So this is the solver. Click on the what do you want to measure? In the previous one, what you have measured? Flatness of this, we'll avoid. Okay? This also flatness we'll avoid. What we measure, we measure the angle. Okay? Angle this with respect to this one. Okay? So what is this plane? Top plane. So go to angle. So this is the angle. This is the angle. Here feature one. Feature level 2. So top plane. So top plane select from here and drag it here. This is actual. This is actual. So drag it. Now this one you have to drag it here. Now nominal value. How much is the nominal value? So you can click on accept. Actual value is what? 49.6495. Now the value is what? Now what we have done? Just to distribute here. Left and right on the right.
की और यहाँ इसमें देखी जाए सर
इसलिए मैंने यहाँ बात की
पता नहीं चलेगा
फीचर लेवल पर फीचर लेवल
यहाँ मेरे काम को करते नहीं रहते हैं सर मेरा मतलब इसमें मैंने किया एस्टैब्लिश हो गया था इसलिए मैं काम किया बनेगा
Okay. Now, nominal distance is 40, 40 and then how much we are getting? 39.39. What is the deviation?
अब मैंने जल्दी
So we are going to see that
हम लोगों ने 5
this dimension given is 40. It is printed on
हो
DLP.
गया पर लगा
But what C is missing? It is coming as 39. Why is it so? It is less
उसको हाथ से पॉलिश करना
compared to the given design which I have made.
फ्लैट रहेगा तब उससे पॉलिश
Because whenever you are printing in DLP as well as SLA, there is some shrinkage happening. Printing is happening at some higher temperature. The result is already heated. So when there is a cooling of temperature, it becomes, it shrinks actually. So that shrinkage is visible here in the form of 39.39 something.
ये वाला देखना थोड़ा
So this is the proof that he has to shrink. And we'll compare how much FDM shrinks, how much DLP shrinks, and how much this composite shrinks. Then
अभी
you know, I will form the number percentage. What else can we find? Find the diameter of this.
इसमें
Find the diameter of this.
बायो इंस्पायर्ड स्ट्रक्चर का बहुत चल रहा
Then option from the called diameter. So click on this diameter.
है तो उसने उसको यूज किया है एज अ शॉक एब्जॉर्बर
हाँ, sir, हाँ, that is wrong.
दिखा भी अभी
एक्सेल पे किसी ने पोस्ट किया था हम ही लोगों ने उसी से लिया कल ही बनाया है तो ये है 2 लेयर का मतलब हम लोगों ने टोटल हाइट उसकी फिक्स कर दी और 50 में 50 ये नीचे के 2 कार से पाए और ऊपर में सॉफ्ट वाला ये प्रिंट करने में ये तो प्रिंट हो गया हम लोग ये नहीं प्रिंट हो पा रहा सिंपल ये ऐसा ऐसा
So nominal actually is
ये अलग है नीचे वाला
जैसे भी पार्ट ऐसे पार्ट
then also it has separate signal.
वैसे भी
Next what you can measure this model and back of cylinder. Front
अब उस सब का ऊपर फिल्टर यूज करते
back plane is front.
हो सकता है तो आप कर दो उसमें
What else? See the plane.
इधर नीचे पड़ा है इधर उसमें दोनों हो सकते हैं यहाँ पे दो किसी चाहिए आराम से फिर
फिर एक ये 2 लेयर लगाए उसके बाद एक ये पहला सिंगल लेयर में और अब एक ही पॉइंट क्या है और एक ये इसका
This is it.
लेयर
Right? So we'll compare. So we still have 2 more samples. Anybody wants to do?
ये सब सीधे पेपर में लग जाएंगे फोटो ये SQL फाइल बेस बेस सबके प्रिंट हो जाता है ये जो नीचे वाला ये सिंपल पार्ट है ये बस नहीं हो पा रहा है ये ऊपर वाला सिंपल स्ट्रक्चर है
These measurements are
छोटी प्रॉब्लम होती है
इसमें ड्रॉप रेट टेस्ट करने के सोच रहे
है नीचे
ड्रॉप रेट टेस्ट या कंप्रेशन टेस्ट कंप्रेशन टेस्ट करना और वो सर बोल रहे हैं सोन से फ्रैक्चर का देखना कहाँ से
So now I replace it. No, let us see the deviation. Yes. So now it is ready. Go ahead and do it. First thing is here on the measurement. Yeah. So we know what the points which you have taken. Click here and then click.
सर वो उसको इतना साफ कर दिया जो बेड है
और उसको ओरिएंटेशन की चीज़
देख लेना एक बार साथ में बैठ के देख
मैं आता हूँ
लेना।
हो जाएगा हमने बहुत इशू किए बात से
थोड़ा से
तुम इथेनॉल
यहाँ पे पेपर
After that we'll come and do.
कितने होने चाहिए?
ऐसा कुछ नहीं है
कुछ भी नहीं है।
ऐसा कुछ नहीं है
मुझे वो करना था
होने वाले तो 4 साल में नहीं होगा एक पेपर निकालने का पूरे 7-5 साल टॉप का निकाल देते हैं हम अभी हमने मेरा अभी मेरा खुद तो 3 होता है शुरू भी नहीं है
अच्छा
अब शुरू हुआ
वो कैसे कौन से पेपर हैं जो
कुछ पिछले हैं सारे जर्नल
एम टेक में
Which one?
काम चेंज किया
Then come on this side and see.
वो किसी से तो जाएगा नहीं लेकिन डिग्री नहीं मिलेगी ऐसा भी सकता है
Printing technology.
पहला पेपर था जो पहला पेपर हम लोगों ने किया था फ्रेंच थिकनेस उसमें फ्रिंजेस दिखते हैं ना टोटल आपस में 2 तरह के होते हैं ब्लैक एंड वाइट और कलर होते हैं हम लोग ये था ब्लैक एंड वाइट वाले वाइट लाइट में देखते हैं स्केलेटन बनाने के लिए थिकनेस है उसके बीच से एक लाइन बना देते हैं सब तो वो एक पेपर पब्लिश हुआ फिर थोड़े और उनके जब रिजल्ट एक्चुअल काम करने लगे तो फिर सोचा कि कलर वाली लाइट यूज़ कर लेते वाइट लाइट यूज़ कर लेते फिर अब वो तो चला गया तो
First of all, you have to manually one thing.
हम लोग को 4 साल के पैसे मिलता था करना भी करना
One part is not simple. They
क्या है
have
स्टेट गवर्नमेंट यूनिवर्सिटी का
so we cannot go and do manually. One
तो
part
अच्छा कंडीशन है हर चीज़ की परमिशन लेने में
So we just send out change the name and keep on this green button. So what happens when you say and then you have to say look this is where this is look this you get or else one more extra you get and after all the measurements will be yes because for making decisions there will be around hundreds of measurements required. Okay. So that will happen automatically. Here the probe is not automatically changing, but there are segments where the probe is automatically angle will be changing. Yes, you can program. Automatically means how you have done it manually.
So the length was increased करना है diameter तो वो ये पर सिंबल में देखना सिंबल में देखना है
एक था बट ये छोटा छोटा हो गया सोचा से थोड़ा बड़ा है
But in production they use this is quite
NC से डिजाइन किया हुआ
they use
फ्यूजन ट्यूब
how big or small it is depends upon the we have multiple measuring units, so all the cylindrical parts can be measured.
T has to be arranged
Yes, only cylindrical parts can be measured. And
आपका कौन सा जर्नल में
big test machine and drag and measure also we can do.
वैसे नेगेटिव में
We have characterization here. So we all the good methods.
जनरल ऑफ इंटेंशन
Characterization.
मार्क्स में हेड करना है सारे
रैपिड प्रोटोटाइप में बना
चलो बुलाने चाह रहे हो फोन आ चल बोला भी था पूरे सुबह से शाम तक सब लोग हमने सुबह से
अटेंडेंस हमारे हाथ में होती इतना टेंशन नहीं होता ठीक है
तो वो कोई दिक्कत नहीं इनसे बात करना
Structural part of it, and this is very
24/7
so half of the last part. So we have to inform the
बहुत अच्छा इंसान से
इसलिए मैं भी ऐसा है
laser DVD and powder DVD as well as Day8. Metal jetting. So that metal jetting is not energy. It was there. Near myself there is a white filter was there. That was the metal jetting. You can accept. Okay. Whatever is done, it is done. Then next. Drag this up. this. Next. Distance between front and back. It means the lean what we are doing, that is wrong. You have taken wrong. For example, you want to measure between, maybe it is this and this. For distance between this curve we want.
Hello?
It's small mistake. Let us go ahead with another. Forget about that. You will measure the distance between this. Right and left. Yes. Now it's over this. Save. Give it an angle of 8 seconds.
हाँ सीधा मत
Save it as 50.
देखते थे जो
Now we'll say comparison.
अपना सब टेस्ट करना चाहिए ನಾನು ಎರಡೇ ಕೊಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದೀನಿ ಅಷ್ಟು ಪ್ಲಾಸ್ಟಿಕ್ ತುಂಬಿ ಕೊಟ್ಟರೆ ತಿನ್ನೋರು ಯಾರು ನಾನು ಅದನ್ನು ಹೇಳಿದ್ದೀನಿ ನೀವು ಟಿಪ್ಪಣಿ ಕಳಿಸ್ಲಿಕ್ಕೆ ಆದರೂ ನಾನು ಹೇಳಿದ್ನಲ್ಲ ನಾ 2 ದಿನ ಇಲ್ಲ ಅಂತ ಹೇಳಿ ನಾನು ಮನೆಗೆ ಬೆಳಿಗ್ಗೆ ಬಿಟ್ಬಿಟ್ರೆ
So here we are getting how much angle? Here I am getting everything is deviating a lot. And here it is almost same. So we are going to see from here SLA that is giving almost equal. FDM it is going much beyond that, much beyond the limit. But here it is equal. In the DLP it is closer. So which is the better one? SLA. We can say directly. Okay, we were thinking theoretically it will be better, but here in the dimension we have found out that dimension is accurate for SLA, then comes DLP, then comes FDM. Okay, so like this we have done. For example, diameter also again. So this is 24 to something. Okay, now I have to check in the software. So okay, we can do the comparison. So now we are got data of SLA. Okay, are you wind up? Again, for doing the measure on first thing is that there are software